Do you know how does YouTube recommend similar videos, or Netflix recommends similar movies or the movies you may like, or modern AI system searches through humongous amount of data and very quickly gives you response? The answer behind all these is something called vector database. In this video, I will explain vector database visually and intuitively. By end of this video, you will be able to understand about the fundamental concepts of vector database, which is the core of modern AI systems. Before understanding the vector database, we first need to know what are the drawbacks of traditional database and why we cannot use it in AI systems. Let's say we have a normal database containing some textual data. Now let's say that I have these three texts which are inside my database, and I want to search all those lines which is having dogs. Now, when in traditional database you write a query, you need to give the exact keywords. Otherwise, it won't be able to give you the right data. If you are querying puppies, which is similar to dog, but will the traditional database will be able to answer you? No, it cannot. Because traditional databases work on exact keyword match. It doesn't understand the semantic meaning of the texts or images or audios. For example, car and automobile are similar to humans, right? However, to traditional database, it's completely different. Now let's take one more example. That you have an image where maybe a dog is running on a beach. How can you store that in a traditional database? You can store the binaries and some metadata like last modified date or some attributes of the image, but you can never able to store the semantic meaning, the color palettes, the details of that image. When you want to search that image from the database, now let's say I am just writing that a dog is running on the beach on a sunset. So it will not be able to give me the record until and unless I provide the exact information about the binary file or exact terminologies or exact specific metadata. That's why searching multimedia through the traditional database for advanced AI systems becomes very difficult. You will never be able to predict what the human query will be. Now, these searches require the exact meaning and the similarity, not the exact match. So you need to have a meaning-based search. And that is exactly where embedding and vector database comes into the picture. Now, in vector database, when you store something, you store in terms of vector embeddings. Now, what is a vector embedding? Let's say a word, dog. When it gets represented to the AI systems or to a vector database, it first gets converted into a numeric representation. And that representation, we call it as a vector embedding. So whenever you are storing any image or a word, so similar words will be having similar sort of embeddings. That's what we store into the vector database. As an example, even though the dog and puppies both are different words, but their vector embeddings will be similar. Think of these vectors as coordinates. Now these coordinates could be multidimensional in hundreds and thousands. Now let's say that there are some words like dogs, puppies, even cats. These would be a bit similar. Cats would be a little further away from dogs and puppies, but it's an animal, right? Whereas car is an automobile, right? So when you do the embedding of car, it will fall way farther from this animal section. Now this space where we plot these coordinates is called a semantic space. Now this is a glimpse of a multi-dimensional semantic space. Now here you can see that different vectors are clustered together. Now there are different colors like animals, foods, technologies, emotions, transport. So all these vectors are forming their own cluster based on the semantic meaning. So if I try to zoom it in, see, so burger, pasta, all these are part of food, right? Taco, steak. So these all form together and these embeddings are close to each other. Now, similarly, if you see some emotions, let's say fear, love, anger, so these will be clustered together. And that's how all the vector embeddings falls into the semantic space. When a user searches, the query gets converted into a vector. And then the vector DB compares that searched vector with its stored vectors, and it finds a closest match. This is called semantic search or similarity search. When this search takes place, that query embedding doesn't get compared with all the trillions of records into the database. Otherwise, it will be very slow. So there are different mathematical algorithms that the vector DBs use, like ANN, approximate nearest neighbors, to find these closest things. And there are variety of different other mathematical algorithms which can be used into these searches. So the vector database calculates the mathematical distance between the vectors. Closer vectors means more relevant meaning. Popular calculation methods include cosine similarity, Euclidean distance. You do not need to memorize the math, just understand that vector database finds meaning through mathematical closeness. Now let's see some real world examples of this vector database being used in any system. Let's say when you go for an Amazon shopping, what do you see? That similar items which you can buy, right? So those are coming from these calculations or similar items or products based on your purchase history. Similarly, when you go to Netflix, if you have some watch history, you will see that Netflix will recommend you some new movies or some other content. So that also comes from the similarity search. Vector databases are also a fundamental block in RAG-based applications. RAG stands for Retrieval Augmented Generation. I have made a detailed video in my YouTube channel of RAG and its architecture. I have given the link in the description. Vector databases are also used in fraud detection, where it detects the anomalies based on the vector similarity search. Popular vector DBs are Pinecone, ChromaDB, Weaviate, etc. But if you want to do some hands-on, I would recommend ChromaDB. In this video, we understand what vectors are, how semantic search work, why traditional databases are not enough for AI, and how vector database retrieves information based on meaning instead of exact word. But this is just the beginning. In the next video, we will go deeper and build things practically. We will also explore using Python and ChromaDB that how to generate embeddings, how to store those embeddings into the vector database, how to do the semantic similarity search. I hope you have liked today's video. If you have done so, please do subscribe, share and like. That's it for today. Take care. Bye.